Hello everyone, this is Dooyoung. The title of the paper that I'm going to review is Not All Areas Are Equal. Transfer Learning for Semantic Segmentation via Hierarchical Reason Selection. Now I'm going to start. As you can imagine from the title of this paper, this is about improving semantic segmentation accuracy. As we all learned from the lecture, semantic segmentation is to segment every pixels into preset classes. It was only available for small images at the beginning, but recently, with growth of deep learning technique, now semantic segmentation is available for large and complex images. Unlike previous approaches that either learn mappings to target domain or fine-tune on target images, this paper proposed methods jointly learn from real images and selectively from realistic pixels and semantic images to adapt to the target domain. So they try joint learning with source images and target images together. But when they apply joint training directly, the results show that the accuracy doesn't increase even when they increase the number of trained images for learning. This is because there are a big gap between source images and target images. As you can see through above two images, you can see the road and it seems like it's filmed in the car. But each pictures have big differences in terms of texture or lighting conditions, something like that. So each pixel in the image and also each pixel in the image have same contributions to the segmentation. So even when we increase the number of trained images, the accuracy didn't go higher. To solve this problem, they propose hierarchical weighting network to select the area in the source images which have similar structure with target image, which lead to similar structure areas contribute more in joint learning. I'm going to tell more details how they designed the model. This is the overview of model architecture. First, they put target images and source images as input, and then they apply GAN to reduce the domain gap between it. After this part, the weighting algorithm is applied. At the pixel level, they feed the target outputs and source outputs, and they map the label result as ground truths with respect to the images. And the region level and image level is also trained in the same way. Then they apply this weight to the source domain and target domain again. Then they do joint training with this weighted source images and target images. This picture is the workflow of weighting map generation. As you can see, 3 levels deliver different weight map, and these results are all applied for hierarchical weighting map. And here are some examples of hierarchical weighting maps. From source image, we will get 3 weighting map and apply this to the original source image. These hierarchical weighting maps are used for joint learning. This is the result of the experiment. And the results show that this paper's weighted method showed the best performance compared to other semantic segmentation methods. If you look at the empathized area, this paper results look more similar to the ground truths compared to the other semantic segmentation methods. As conclusion, they introduced a new transfer learning method with both real and synthetic images for semantic segmentation. They mitigated the domain gap between insufficient real data and abundant synthetic data by adaptively selecting similar synthetic pixels for learning. Hierarchical weighting networks are used to score how similar the synthetic pixels are to real ones at pixel, region, and image levels respectively, which helps us adapt to target real images. Also, we learned weighting networks and segmentation network jointly in an end-to-end manner. This is all my presentation and thank you for your attention.